So we're going to now look at question 6b part 2 from the 2014 National 5 Physics paper. And it says use information from the graph to determine the half-life of the radioactive source. So if we look at the graph, we want to use this graph to determine the half-life of the radioactive source. Now, I can't quite get the graph into the screen, but we can see that the graph starts at this value here, which is about, in fact not about, exactly 2, 4, 6, 8, so that's 88 is the corrected count rate, counts per minute. And so we want to determine the half-life, and so the best way to do this is to figure out what is the half of 88. So if we go down here, the half of 88 is 44, and so what we can do is we can draw a line across from 44, just here, if I can get this right, to where it hits the graph, and then we can draw a line down to the bottom, and we can see that that line lines itself up with the number 10, and that's 10 minutes. And so therefore, effectively what that means is whenever the activity falls to half its original value, which was from 88 down to 44, that process takes, as we can see here, 10 minutes. And so therefore our half-life is 10 minutes. So what we want to do is record that down where we have the question, determine the half-life. We've done that, it's on the graph. You may well want to draw that on the graph precisely, but you can write your answer as 10 minutes. You can write it as MINS, that's fine, or you can use MINUTES as well. It's not a good idea to do 10M, because M is not the abbreviation for minutes. That looks like 10 meters. So definitely don't write it like that. That's the way to write it.